Hello everyone, welcome to this video. In the previous video we saw several properties regarding to the Fourier transform. Now let us build on to the first property, which is easiest of all, which is the linearity property, right? So now this linearity property, what does it do? It creates a sensation that the Fourier transform is a linear operator, and moreover the inverse Fourier transform, that is also linear in nature. Now what do you mean by linear? That means suppose if you have two functions, one is f of t and another is g of t, they both are piecewise continuous. One thing, they are given to be piecewise continuous, and additionally they are given to be absolutely convergent. So in that case, we are able to define the Fourier transform of these two functions. So what would be the Fourier transform of the function f of t? We already know. Using definition, it would be integration from minus infinity to infinity f of t e to the power minus iota omega t dt. And similarly for the Fourier transform of the function g of t, it would be integration from minus infinity to infinity g of t e to the power minus iota omega t dt. So that means we just have a change over here in this function. So now that means if you already have the Fourier transform of these two functions, and you are now required to calculate the Fourier transform of the linear combination, suppose a and b, they are constants, so we are asked to calculate the Fourier transform of this linear function, then what would it be? So because this Fourier transform according to linearity property is a linear operator, right? So we can write this to be equal to a times the Fourier transform of the function f of t plus b times the Fourier transform of the function g of t. So this is what the linearity property tell you, that you can separate out all these terms and you can take out the coefficients, the scalar terms a and b outside, right? So this is our linearity property. Now let's move ahead and try to see how this is true. So for that, let me consider the left hand side. So that means I'm calculating the Fourier transform of this linear combination a f of t plus b g of t, right? So what would it be? So let me apply the definition. According to definition, it is integration from minus infinity to infinity whatever function that is given to you e to the power minus iota omega t dt, right? Where what is this omega? This is the frequency, and our function that is given to us is this one, a f of t plus b g of t, right? So now what I can do, I can open up this bracket. So I have the terms integration from minus infinity to infinity a f of t e to the power minus iota omega t dt, and not dt, it would be plus b g of t e to the power minus iota omega t, and whole thing I have dt. Now because integration is a linear operator, we very well know it, right? Integration is a linear operator, so I can separate out these two terms, the integration over these two terms. So it would be simply integration minus infinity to infinity a f of t e to the power minus iota omega t dt, and then it would be integration minus infinity to infinity b g of t e to the power minus iota omega t dt, right? So what I have done, I have just separated out these two terms. Now what else I can do? Because this is a linear operator, so a and b being constants, they could be taken out of this integration sign. So we can write this like a integration minus infinity to infinity f of t e to the power minus iota omega t dt plus b integration minus infinity to infinity g of t e to the power minus iota omega t dt. Now look at this term and this term. What are they? They are nothing but they are the Fourier transform. This first term is the Fourier transform of the function f of t, and the second term is the Fourier transform of the function g of t. So this is nothing but your right hand side. So you have proved that this operator of Fourier transform, this is a linear operator. So I hope you understood this property. This is the easiest of property. So in the next videos we'll see some more properties regarding and relating to this Fourier transform. Well, that is it for this video. Thank you for watching.